Okay, guys. I was trying to edit the other video and it wasn't working very well because I don't know what I'm doing. So, let's talk to Chloe about that one. Excuse me. Alright, so the video that I'm going to get into, or the book that I'm going to get into, rather, is going to be The Self-Sufficient Backyard because I have not done any out of these books in a while. So, back into these. And this one is on Homestead Water Filtration. Don't think I've done that one yet. I don't think. Oh, maybe I have. Hold on, guys. See if I can find it. Water filtration. I may have done it. I think I might be on the next one. Is this what I get? Maybe I haven't. Let me see. I'm gonna go at Faith First Farm and Homestead. I'm surprised it's not just bringing it right up. Okay. Alright, well, I have to search for it the other way then. And my battery's getting low, damn it. Piston pumps. Well disinfection. Homestead water filtration. Okay. So I did do it. I thought I did. Okay. Alright, so the next one is Homestead Hot Water. Sorry, guys. This one's a little bit longer. Okay. Here we go. This will be pretty short. A little bit longer than the last one, though. On the water filtration. If you need hot water, just take a pot of water and set it on a stove. Set it on a stove to heat. Once it is the desired temperature, pour it into your cast iron bathtub. Adjust water temperature with a splash of cold water from a bucket, and voila, hot water for a bath. And after all, isn't that what everyone does? Of course, I say that with a bit of tongue in cheek. Running hot and cold water are taken for granted in this day and age, and yet it wasn't that long ago that all of our homestead water was hand pumped and bucketed into the house in Maine. In Maine, we did that for 20 years until we modernized. Heating kettles of water on one of our wood stoves was how we always heated water for bathing and laundry. And when all else fails, say for example the power goes down, a pot of water heated on a wood or gas stove will get you some hot water too. There are any number of ways to heat hot water for the home. Typically, a home has either an electric, gas, or oil hot water tank. For anybody wishing to live off the grid, forget the electric powered water heater. It doesn't make sense from an energy consumption perspective. It takes a lot of electrical power or watts to raise the temperature of water adequately for daily use. That power could be put to better use elsewhere on the energy efficient homestead. Having said that, If you are hooked to gas or electric utilities, you can save money and be more self-sufficient if you were to consider a system that preheats the water in solar panels made for this purpose. We have not had any need to do something like that since we use wood or heat to heat our water. But the concept is simple enough. Before the cold water supply gets to your gas or electric water heater, it is preheated by circulating through a solar panel usually mounted on a roof. There are many variations of preheaters, with some using glycol or antifreeze combined with heat exchangers. We don't really want to do that. Preheaters can be made homemade as well. Depending on the climate you live in, it may even make sense to set up a solar system solely for the purpose of heating your domestic hot water and have the gas or electric as a backup if the solar system needs to be shut off for maintenance or repairs. The sun's energy is free for the taking, whether it produces electrical energy is used for water or heating, is used for food drying, and yes, even for home heating. I've built and lived in remote exploration camps that have used on-demand propane water heaters, and that's certainly an option to consider too. For an off-grid or energy-efficient home, it's a more practical solution than an electrical hot water tank. But it relies on a source of gas, whether it be piped in from a utility company or from gas cylinders purchased and rented from the local propane company. Whether one relies on the electrical utility or the gas utility, a person is still dependent on others to supply a vital service. For us, it made no sense to purchase cylinders of propane and then fly them into our wilderness homestead for heating water, especially when we were surrounded by millions of acres of forest. Additionally, we would lose one of our self-reliant aspects by relying on the gas plant and float planes. So we opted for a method of heating our water that uses our wood resource. It's said that heating with wood warms you twice. When you cut it from the forest and stack it, and then when it's burned in the wood stove. We've taken it a few steps further by not only cooking our meals with it, but also by using it to heat our domestic hot water. It's kind of what I'm thinking too. I discussed the hot water setup we had at the main homestead, the most basic system possible. For 20 years, we lugged in buckets of water by hand from a hand pump outside, poured the water into pots, set the pots on one of our wood stoves to heat, and then we carried that hot water to the tub, sink, or washer. This was great for building muscle and character. But yikes, there had to be a better way. And there is a thermosiphon loop. Our Saskatchewan homestead had a piston pump and pressure tank that drew from a hand-dug well. That pump and pressure tank combination supplied pressurized water to the house. A wood cook stove in the kitchen set up with a thermosiphon loop and a storage tank provided our off-grid homestead's hot water. We have installed the same system here at our Nova Scotia site. Don't let the fancy term thermosiphon loop intimidate you. It's a simple concept. Just as hot air rises, hot water does as well. We utilize that principle by plumbing a standard home water heater set up next to our stove. It's roughly a 50-gallon tank, and that's all it's being used for, purely a storage tank. We set up plumbing from the tank to the stove's water jacket to take advantage of the flow of heated water. The water jacket is a container that sits on the inside of the stove's firebox. There are 2 threaded ports where pipes can be connected. As water is heated in the jacket, it starts to flow upward and into the top of the water tank, and then is replaced by colder water coming out of the bottom of the tank. This is a simple and efficient method of taking some of the heat from the wood stove and using it to raise the temperature of water for household use. It works great and it's free. There's no need for any inline pump since the water circulates on its own. The size of the tank is balanced with the size of the stove so we don't end up with a tank of boiling water, which would happen if we had a much smaller tank. But the water does get hot. Modern day water tanks are extremely well insulated so the water stays hot for days even if we have no fire in the stove. There are many ways to plumb thermosiphon loop systems using copper tubing and fireboxes around chimney pipes or on the exterior of a wood stove. If you understand the basic concepts, you should be able to utilize a wood stove to either fully heat or preheat water for your homestead. Regardless of how you use the wood stove to heat water, don't forget to install a pressure relief valve. So I'm going to have to remember that. Of which I don't have a pen right in a second. Sorry. Although we chose a standard hot water heater as our storage tank, There are tanks made just for this purpose. Another name for them is range boilers, some of which are made of copper. Hang on, sorry guys.
I want you to.
Because both our water tank and stove jacket have a 3/4 inch pipe threads, I chose to use a combination of 3/4 inch copper and galvanized iron pipe to make all of my connections. That would be the minimum pipe diameter I would ever use in a system. Some of our astute readers might wonder about connecting dissimilar metal pipes. Galvanic metal corrosion is the issue here. When two dissimilar metals are connected in the presence of an electrolyte, one can get some corrosion. All I can say is, from my experience, it's not an issue. We use PEX plastic tubing for all of our main plumbing throughout the house, and I suspect that provided some insulation. I'd probably be singing a different tune if the house plumbing was all copper tubing with galvanized pipe connections to the hot water tank. The water tank has a sacrificial anode that will corrode, and it also helps protect the water system. It's a good idea to check that anode by removing and replacing if necessary. The anode, ANODE, has always been located in the top of our water tanks. If in doubt, use a brass coupling between the copper and galvanized pipe, since brass doesn't react with either metal. Something for you to keep in mind. I should mention that initially our Saskatchewan house water tank to stove connections were all galvanized iron pipe. But I found over time the galvanized pipe coming out of the stove would fill with brown goo that needed to be cleaned once a year. Our whole house had filtered water, so I really don't know what the brown sludge was. Nevertheless, that's when I decided to try copper pipe for my loop in and out of the water tank to the stove. The goo was never a problem again. Copper seems to be the best choice to plumb our system. I have 2 couplers in my copper plumbing so that if I need to remove the water tank, it's an easy job of disconnecting the couplers and the tank is free. Alright. I'll probably just take a picture of that and then use it. Let's take a look at our thermosiphon setup. You will note a number of things in the picture. The cold water inlet to the tank and the hot water outlet have a shutoff valve. That way I can shut the hot water off going to the house if need be or prevent cold water from going into the tank. I also have a valve on the tank outlet that goes to the stove's water jacket. There are a number of very important points I'll make. As with any hot water system or potential steam arrangement, safety is paramount. It is critical that this valve remain fully open under normal circumstances. Tag it, tape it open, or put a small wire tie on it so that it can't be inadvertently shut off. I want that valve there so that if my stove, jacket, or plumbing happens to spring a leak, I have a way to shut down the tank outlet and prevent the tank's contents from draining onto the floor. We did have a situation where the water jacket developed a leak and that valve came in handy. Here's what happened. We found out the hard way that it is very important to have water in the system before making a fire in the cook stove. One winter we had returned home from a vacation and I didn't have a chance to get the water up and running before Johanna started a fire in the wood cook stove. Because of that, our water jacket cracked. When I did fill the system with water, it was obvious that something was amiss when water started coming out of the stove onto the kitchen floor. The moral of the story is the water jacket must have water in it before getting a fire to go. Another critical component of the system is a minimum of 1 pressure relief valve. 2 is better. If for some reason the water gets too hot, it has a place to vent and release some of that built up energy. To install a pressure relief valve, locate the port going directly into the tank side and put the pressure relief valve there. The second relief valve should be located close to the outlet of the stove jacket. The water coming out of that port will be the hottest. A T inserted in line at that point with a pressure valve will keep you safe. Plumb both relief valves to the home's drainage line or bucket. The second pressure relief valve up at the tank is simply a backup for safety. Unless Johanna is canning the entire day in summer or cooking the Thanksgiving turkey, rarely do we ever get water hot enough to open that pressure relief valve. We have enough experience to know when this system is building too much hot water and we just open a tap and let hot water run down the drain. It's a balance between the tank capacity the amount of hot water taken out of the system on a daily basis, and the duration and intensity of the wood fire. Only experience over time will tell you whether you need to modify your tank size. The last 3 points I'd like to make are: make sure the water tank range boiler is higher than the bottom port of your stove's water jacket. The idea is that you want the cold water in the tank to fall out of the bottom pipe and into the water jacket. If, for example, you had the tank lower than the water jacket, you would be asking the water to flow uphill into the water jacket. Our tank's bottom port is 6 inches above the bottom port of the water jacket, and it works just fine. The next point you'll notice is that I have a pressure gauge on the top of the tank on the cold water inlet. Although I have a pressure gauge downstairs in the cellar near the water pump, this is a more convenient way for me to monitor with a quick glance the status of our water system and pressure. And finally, take note of the drain valve and nearby fire hose. The drain valve is handy for draining the tank for cleaning, or if we go away for an extended period in the winter and have to drain all water out of the system so it doesn't freeze in an unheated house. The fire hose serves 2 purposes. I can run the hose outdoors to facilitate easier tank draining. And if the unthinkable were to happen and the house catches fire, if we act fast, it might be possible to save the place by spraying the contents of the tank on the fire with the fire hose. It is our responsibility to think ahead and give ourselves a fighting chance. Please consider placing a fire extinguisher handy next to your wood stoves too. Alright, and the next one is on rainwater catchment. And that's definitely towards us. And I'm going to take a picture of that tank. And then I'll use that for the cover for the video. That was Homestead Hot Water. And I will go ahead and get off from here, and I'll get this up there, and I'll just work on getting more up. So I will see you guys in the next one. Bye, guys.